So good afternoon, one and all. So I will be giving a talk on basic introduction of artificial intelligence. Um, so what is artificial intelligence? So we will discuss one by one. So artificial intelligence is the simulation of human intelligence processes by machines, especially computer systems. And these include three components. First is learning. Learning means the acquisition of information and rules for using the information. Next is the reasoning. Reasoning is using rules to reach approximate or definite conclusions. And third is the self-correction or self-validation. Yeah. So this technology of artificial intelligence, it is growing interest from organization and various industry. As you can see, it wants intelligence. So organizations like in all the sectors, like whether it is medical or life sciences, developmental tools, finance, media, government, everything wants artificial intelligence. And you can see day by day, year by year, the use of artificial intelligence in all the industries are increasing by leaps and bounds. Next, there are the big players, the companies which play a role in AI. These are the major and well-known companies are Facebook, Microsoft, Google, IBM, NVIDIA, Baidu, and Amazon. The startups given for artificial intelligence, and it is helping also in the medical sectors. Basically, some of the companies which are very famous, like MetaMind, Clotica, Signal Science, Numenta, and Vicarious, and DeepMind. And even the IBM company Alchemy, which is now very prevalent in India. So coming on to the basic coverage of artificial intelligence. So basically it includes all these components, as you can see here. Artificial intelligence includes the way planning, then robotics, then machine learning, natural language processing, perception, knowledge, cognitive system, all this. So we will discuss in details one by one in the coming slides. So come on to the artificial intelligence basics. So what is actually this technology? So the objective of this AI is to automatically detect and measure the pathologic features in images of the eye. So the methods which it uses are, it analyzes pixels or labels and group of pixels in fundus photographs or three-dimensional voxels in OCT images in some way. Now for this, we have variety of approaches. So the first approach this is called as the simple automated detectors by pattern recognition. This is the simplest form of artificial intelligence. Here programmers give the software mathematical descriptors of the features to detect and rule-based algorithms for searching these patterns on incoming images or the pattern recognition. So these all positive hits means the correct pattern recognitions are combined to produce a diagnostic indicator. The second step by which we can use artificial intelligence are the basic machine learning. In this approach, the algorithm is given some basic rules about what disease features look like, along with a training set of images from affected and unaffected eyes. So the algorithm examines the images to learn about the differences. Third is the advanced machine learning. This type of machine learning structure consists of one or two interconnected layers of small computing units called neurons, which mimic the multi-layered structure of the visual cortex. So each layer contains data of one or more variables or characteristics. The inputs to the first layer are the same disease feature detectors used in the basic machine learning. However, the outputs of the neurons in each layer feed forward into the next layer for further analysis by the data of that layer. And the final layer yields the diagnostic output. So it's like a web of information going from first layer to the final layer. Thus, the neural network learns to associate multiple specific inputs of disease feature detectors and results in a more accurate diagnostic output. So in this, you can see this is an illustration of supervised learning, the way computer algorithms are taught to recognize pattern. So in this case, the process shows how computer algorithms are taught to recognize features of retinal diseases encoded in retinal images and the errors are penalized as the algorithm repeatedly cycles through a large set of images. The algorithm remembers the previous errors that resulted in penalties and constantly tries to avoid them. In other words, with each cycle, the algorithm tries to make increasingly correct guesses and eventually learns how to make the correct diagnosis. So it is clearly explained in the illustrative diagram here. So the fourth step for artificial intelligence, or the layer, is the deep learning with convolutional neural network, or we can call it as CNNs. So now this deep learning is used because there are multiple interconnected layers of neurons. And because they perform their tasks through repetition and self-correction, this new approach leads to latest iteration or software of AI. Thus, it comes closer to resembling thinking like us. Like us means the human beings or ophthalmologists. Okay, so this is, and now it comes to the very most important part of artificial intelligence, that is called as a disease feature based versus image based, that is black box learning. So we should explain, like we should know this in details. So till now, machine learning algorithms are multi-layered data algorithm based on clinically known characteristics of diseases such as hemorrhages or exudates. So it is supervised learning algorithm. Here, scientists can verify that its output is based on the presence of the same image characteristic that a human would identify, and they can adjust the algorithm if necessary. But this is the supervised learning algorithm. But however, Google has developed a successful system called Google Brain in 2016. Now, this is unsupervised black box system. In this, what happens in Google's deep learning algorithm teaches itself to correctly identify diabetic lesions in photographs, even though it was not told what the lesions look like. So what's so exciting with the deep learning is actually scientists are not yet sure what and how the system is looking at, but all they know is that it's arriving at a correct diagnosis as often as ophthalmologists are. Ultimately, artificial intelligence acts as a complement to the skills of physicians to provide better care for their patients. But this unsupervised black box system unsettles some specialists with fear due to unsupervised approach, but fascinates others. So you can see here is lesion-based disease detection. The retinal images is quality assessed, and if it is a positive hit, means if it matches with the artificial intelligence data, so it is called as a pass. Now there is called as a lesion detection here. So lesion is detected, anatomy is localized, and then the disease assessment is done. In this case, as you can see, that it is detecting diabetic retinopathy where DR is positive or DR negative, so it detects like that. Now, black box means it is an unsupervised learning system. So it uses the images there, and it directly, without any like this quality assessment and pass, it will feed it images which is in the Google Brain software. It directly leads to the correct results. So sometimes it is a correct results, and sometimes it might not be. So this is a neural nets called as how do unsupervised deep learning system know what they know and come to conclusion. So now this opacity, it troubles many artificial intelligence researchers. So it is as you know, it's a next transformation is ophthalmology. So here we will explore what artificial intelligence means for practicing ophthalmologists, its promises, limitation, and what the future holds. So basically, it is going to create a revolution in ophthalmology. It is already starting with the retina. The work is mostly done in this sector. So most immediately promising computer algorithms are the field of retinal diseases. So it is accurately detect diabetic retinopathy with much sensitivity and specificity, and diabetic macular edema. And in other retinal conditions also, it is very useful as in ARMD, ROP, and retinal pseudodrusen. And the research is going on in the other sectors of ophthalmology, in pediatric cataract, glaucoma, keratoconus, or corneal ectasia, or oculoplastic reconstructions. So here I'm just going to brief about DR because my upcoming speaker will be doing that in detail. But like I'm just going over a very brief here. So it is used for the retinal diseases for detecting diabetic retinopathy and diabetic macular edema from fundus photographs. And its potential is to provide more efficient and objective analysis of images and prediction of disease progression. Now, there is an FDA approved AI based tools there are three tools which are approved as of now by US FDA. Is LVO stroke platform. It was approved in February 2018. IDX DR device was approved in April 2018 and it is the first artificial intelligence system in ophthalmology. And OsteoDetect was approved in May 2018. It is used to aid in the detection and diagnosis of wrist fracture in adults. Okay, so I'll just wrap it up. You can see like it's IDX DR device is used for the detection of diabetic retinopathy, even its application in the ROP, even in ARMD. So, and even in the corneal topography, the analysis is done a better means for predicting ectasia, even in IOL powered selection using artificial intelligence. Okay, so now, and even in glaucoma, and it also predicts heart disease by looking at your eyes. But okay, so I'm going through my last slide. The current limitations of AI was the quality of the training sets, the problems with image quality, black box dilemma, and the wrong answers.
Appreciate Dr. Aditya. Please wind it up.
Yeah, but like the last slide, yes. It was finally I just might it's a last point. It is an augmentation. It's not replacement of specialists. And final decision and management will depend on specialists based on the artificial intelligence. A lot of research are going on in other institutes in ophthalmology. So whatever be the pros and cons of AI, it is going to play a big role and will fuel a medical revolution in next 10 years by enabling far more efficient drug delivery, diagnosis, and research. Okay, thank you for your kind attention. Thank you.